Climate is the average weather in a place over many years. This can be measured by taking the averages of things like precipitation and temperature. Climate is contrasted to weather in many ways. For example, climate is measured over long temporal time frames, while weather is what's happening currently outside. Additionally, climate spans large geographic regions, while weather is more localized or regional. Climate can be influenced by a number of abiotic and biotic factors. For example, climate becomes colder with altitude, wind patterns influence seasonal effects, and topography can contribute to natural phenomena like rain shadows near mountain passes. Additionally, biotic processes are influential. Through the process of photosynthesis, carbon dioxide, or CO2, is drawn from the atmosphere by plants to create carbohydrates needed for energy. Also, through plant transpiration, microcooling occurs. The natural greenhouse gas effect ensures climate regimes that make life suitable on Earth. Without this process, Earth's climate wouldn't be much different than other planets in our solar system. For example, Earth could have extremely cold temperatures like Pluto, extremely hot temperatures like Venus, or extremely variable hot and cold differentials like Mars. The balance of trapping greenhouse gases in the atmosphere and radiation input and output make life on Earth possible. This video explains the greenhouse gas process. Earth's climate has always been naturally variable. The position of the Earth to the Sun, natural cyclical climatic processes like North Atlantic Oscillation and El Niño Southern Oscillation have always influenced Earth's climate. Additionally, the Earth has gone through several ice ages and deglaciation events. This natural variability is either controlled externally or internally. External controls are orbital parameters of the Earth, while internal factors result from the interaction between the ocean and the atmosphere and the biosphere. What's alarming is that this natural variation cannot explain all of the climate variability that has been occurring over the past several decades. Human activities over the past century have altered this natural greenhouse gas process by introducing excess CO2 into the atmosphere. Through increased electric power usage in thermal plants, increased use of fossil fuels, and increased nitrous oxide emissions from fertilizer use, excess CO2 has entered the atmosphere. And of course, these aren't the only means of excess CO2 emissions occurring today. Before the Industrial Revolution, atmospheric CO2 concentration was around 270 to 280 parts per million. As of February 2017, CO2 atmospheric concentration was above 406 parts per million. Atmospheric concentration has been rising more than 1.5 parts per million annually over the past century. The consequences of increased atmospheric CO2 results in unpredictable weather and rising sea levels. According to the Intergovernmental Panel on Climate Change, if we proceed forward with business as usual, by year 2100, sea levels will probably have risen 9 to 88 centimeters, and average temperatures will be between 1.5 Celsius and 5.5 degrees Celsius higher than current temperatures. This may not seem like a lot at the onset, but the last ice age occurred when temperatures were between 4 and 5 degrees Celsius cooler than current temperatures. We have already seen an increase in global surface temperatures of 0.6 Celsius in the past 140 years. We can see the evidence of climate change by looking at global sea ice coverage. Over the past century, glaciers have been receding at alarming rates. Not only does this confer negative impacts on wildlife and other communities, the melting of Arctic tundra could result in positive feedbacks. For example, higher temperatures may release more methane from the Arctic tundra and CO2 from peat bogs, which will in return speed up the process of warming. Additionally, different techniques and studies have indicated a significant increase in surface temperatures globally. This increase is projected to further exacerbate current freshwater stress and scarcity among densely populated regions and regions that are already under extreme freshwater shortages. Empirical data demonstrates sea level rise has occurred and will continue to do so. Geological observations show an increase in sea level rise of 6 centimeters during the 19th century and 19 centimeters in the 20th century. With each degree Celsius of temperature rise, it is projected sea level will rise approximately 2.3 meters, which is about 7.5 feet. More than 634 million people live in coastal areas within 30 feet of the sea level, and about 2/3 of the world's megacities are located within these low-lying coastal areas. Future sea level rise could devastate many of these communities, not only costing billions of dollars, but also many lives. The devastation that could occur due to sea level rise reinforces the idea that it will be paramount to utilize adaptive management practices in social ecological systems.
We used to ask the question, is climate really changing? And what evidence do we have for the changing climate? Today there's plenty of evidence, as shown in the general overview PowerPoint presentation on climate change, that climate change is real and it is happening. Today, not everyone believes in climate change, but there has been a change in focus because more and more people are victims of climate change-caused impacts like floods and drought. So even if people don't believe in climate change, they want to avoid disasters and prepare for them. More people have started to ask whether we can manage climate change-caused negative impacts and prepare ourselves for these changes. There are two different strategies that try to cope with climate change: mitigation and adaptation. Mitigation refers to the efforts made to reduce future climate change, such as, for example, reducing greenhouse gas emissions through various policies. Adaptation is about adjustments or actions made to reduce vulnerability of society to the impacts of climate change. At its core, climate change is a very thorny problem of scale. Climate change involves drivers or slow variables such as greenhouse gas emissions that are planetary in scope or in scale. But the impacts of this climate change can be felt at all different smaller scales as well, regional, local. They can be disproportionate in certain areas, such as coastal areas that are much more vulnerable to sea level rise and to extreme weather events. They can be disproportionate on populations, such as urban populations or the elderly and women and children. So what this means from a practical standpoint is, while mitigation is certainly very important, more local scales cannot rely solely on mitigation, because any mitigation acts that they take, it's going to be dependent upon what everybody else is doing. What they can do is to prepare themselves to adapt for the effects of climate change. And that's why we focused this presentation on adaptation. And we'll talk about it particularly in terms of the United States and what's being done there. Now, adaptation can be done reactively and proactively. Reactively is simply meaning after changes in climate have already occurred. Proactively, more on a planning basis. There's no one-size-fits-all solution, and it depends really on things like the context, the local circumstances, and the local culture and capacity for adaptation. And these proactive preparation strategies can reduce harm for all different types of climate change impacts, such as increasingly intense weather events, shifting zones for agricultural crops, really any kind of impact from climate change. Leadership, guidance, information, and support from the federal government are all vital to planning for and implementing adaptation actions at all scales and in all affected sectors of American society. In recent years, there have been several new federal climate adaptation initiatives. For example, federal agencies like the EPA, NOAA, are all required to plan for adaptation. By facilitating adaptation, through things like emergency management, ecosystem conservation, supporting a clearinghouse to share data, giving of assistance in disaster response, and just generally educating the public. The EPA has a Climate Change Adaptation Resource Center that provides climate change adaptation training as well. However, the question remains, what is the situation now in 2017 with respect to the federal government's stand on climate adaptation? There have been indications that the new administration does not share the same level of concern with climate change and climate change adaptation, so it remains to be seen how the federal government on a going forward basis will handle climate adaptation. States have become important actors in United States climate change related efforts. They can create policies on a statewide level, and they can also create policies and programs with respect to adaptation at smaller governance scales such as counties or regions. Though many of these actions aren't specifically designed to address climate change, they'll include a climate change adaptation component. Many of the state-level climate change adaptation actions focus on planning, and the result or the deliverable is basically a document or plan that lays out what actions should or will be taken. On the map, you can see that as of 2013, about 16 states have some sort of state climate adaptation plan. 2 states were in progress, and some states have a recommendation for one, meaning that they're basically thinking about it. Texas does not have such a climate adaptation plan on a statewide level. Some states also create sector-specific plans that consider long-term climate change impacts like biodiversity conservation plans. Some have also created legislation or other programs that directly or indirectly target the reduction of climate vulnerabilities. An example of this is the Louisiana Comprehensive Master Plan for a Sustainable Coast, which includes both protection and restoration activities addressing land loss from sea level rise, subsidence, and other factors over the next 50 years. We'll talk more about the Louisiana experience and the Louisiana plan in the case study for this segment. Most climate change adaptation efforts have occurred at the local and regional levels. For example, many cities have built climate change adaptation and mitigation actions into their various departments. Austin has done so under sustainability, and one of the ways it tries to address climate change is through things like the Austin's Urban Forest Plan. Local governments are using land use planning, also provisions to protect infrastructure and ecosystem, also regulations related to the design and construction of buildings, roads, and bridges. For example, in Portland, Oregon, they updated the city code to require on-site stormwater management for new development and redevelopment. In addition to local governments, regional agencies and regional aggregations of governments are becoming significant climate change adaptation actors. For example, in San Diego Bay, 5 municipalities partnered with the port, the airport, and more than 30 organizations with direct interest in the Bay's future to develop the San Diego Bay Sea Level Rise Adaptation Strategy. The strategy identified key vulnerabilities for the Bay, as well as adaptation actions that could be taken by individual agencies and through regional collaboration. Tribal governments have been active as well in preparing for climate change. For example, in Newtok, Alaska, the village council is leading a land acquisition and planning effort to relocate the community because climate change has induced coastal erosion, which has destroyed essential infrastructure, making current village site unsafe. The Tulalip tribes in Washington state are using traditional knowledge collected from elders in the form of stories and songs, and they're combining this knowledge with downscaled climate data to inform decision-making relating to climate change adaptation. Non-governmental entities have also been significant actors in the national effort to prepare for climate change. They do this by providing assistance that includes planning, guidance, implementation tools, contextualized climate information, an exchange of best practices, and help with bridging the science policy divide to a wide variety of stakeholders. Non-governmental entities have also been significant actors in the national effort to prepare for climate change. We do this by providing assistance that includes planning, guidance, implementation tools, contextualized climate information, an exchange of best practices, and help with bridging the science-policy divide to a wide variety of stakeholders. With respect to the private sector, organizations like the Carbon Disclosure Project and the Securities and Exchange Commission's Climate Change 10K disclosure indicate that a growing number of companies are beginning to actively address climate change risks. For example, the Coca-Cola Company is working around the world to replenish the water used in its finished beverages by participating in locally relevant water projects that support communities and nature. Since 2005, the Coca-Cola system has engaged in more than 320 projects in 86 different countries. The range of these community projects includes things like watershed protection, expanding community drinking water and sanitation access, water for productive use such as agricultural water efficiency, and general education and awareness programs. With all of these different adaptation activities, general patterns in the adaptation processes are beginning to emerge, with similarities that are discernible across sectors, systems, and scales. This is broken down into basically 5 different steps, but it's important to note that this is not a linear or stepwise process. This means that various stages can be occurring at the same time, they can occur in a different order, or some steps can be omitted completely. The first step is identifying and understanding risk, vulnerabilities, and opportunities. In this regard, different types of qualitative and quantitative methods are utilized to try to understand climate vulnerability and risk. This would be like case study analyses, scenario analyses, monitoring of key species, or peer information sharing. Once these risks and vulnerabilities are understood, the next stage generally involves identifying, evaluating, and selecting options for responding to and managing potential climate change impacts. These can involve participatory approaches that integrate a variety of stakeholders, such as having community members and governing institutions work together to define the problem and design strategies that will both work and are sensitive to the values of the various stakeholders involved. Regional collaboration has emerged as an effective strategy, and in many cases, these approaches to adaptation and planning include mainstreaming or integrating climate adaptation into existing management plans or scenarios. The next 2 stages are implementation and monitoring and evaluation. There isn't much peer-reviewed literature on either one of these categories, and sometimes it's difficult to figure out how to understand and assess the efficacy of these types of actions because they're tied into things beyond just purely climate adaptations. The final stage is to revise strategies and processes and to share information. And this is just generally part of the iterative adaptive process through which stakeholders evaluate the appropriateness of the activities that they've implemented and revise them as new information becomes available. There are many different potential barriers to adaptation activities. These would include things like a lack of climate education and just the inherent uncertainties relating to future climate impacts. Also, the mismatch of decision-making timescales. Other barriers would include a lack of financial resources or a fragmentation of the decision-making structure, including both the fragmented jurisdictional boundaries and the lack of coordination within and across various agencies, companies, and NGOs. There are also institutional constraints, such as a failure to have a legal mandate to act or rigid laws and regulations that make action difficult. Leadership, an absence of leadership can also be a problem, which also deals with polarization and these rigid and entrenched political structures that make action or change difficult. And one final barrier, potential barrier to adaptation, is divergent risk perceptions, cultures, and values. Basically, this is the cultural aspect of the picture, conflicting values or perceptions of risks among different groups, resistance to change, and just general cultural taboos. Climate change adaptation is in its very beginning stages. Despite all of these emerging efforts, however, the pace and extent of the adaptation activities to date are not proportional to the level of the risks that people, property, infrastructure, and ecosystems face from climate change. In terms of the next steps for adaptation, one of the key overarching issues relates to enabling research and development to advance adaptation across various scales, sectors, and disciplines. This includes, importantly, social science research addressed at overcoming the various barriers for change that were just discussed on the last slide. Other types or other steps for adaptation include the following. First, methodologies need to be implemented to evaluate the relevant costs of the various adaptation options as well as the costs of inaction. In addition, it would be helpful to have a central and streamlined database of adaptation options that have been implemented at different scales in space and time. This would include information on how effective they were, what they cost, and how monitoring and evaluation were conducted. Another important area for future research is with respect to how mitigation actions and adaptation actions affect each other and the feedbacks involved between the two of those. Also needed is further research to identify the critical thresholds or tipping points beyond which social and ecological systems are unable to adapt to climate change at all. Finally, research on preparedness and response to extreme events such as droughts, floods, and storms is required in order to protect people, ecosystems, and infrastructure. The assigned reading discusses 4 different case studies with respect to the various types and scales of climate change adaptation measures being utilized in various places throughout the United States. The first one is national in scope, involves the National Integrated Drought Information System. This is a federally created entity that was designed to improve the nation's capacity to proactively manage drought-related risks instead of being reactive. It provides various things. These include a drought early warning information system that provides regional detail concerning onset and severity. Also, a web-based portal and coordination of federal research in support of the use of these systems. And finally, the leveraging of existing partnerships and of forecasting and assessment programs that provide greater and more detailed information. The second case study involves adaptive governance in the Colorado River Basin. The Colorado River supplies water and valuable ecosystem services to over 30 million people. It is vulnerable to climate change because of decreases in the mountain snowpack and water availability, fires, drought, invasive species, and increased water competition among water users. In 2011, the Western States Water Council, together with 11 federal agencies, created a work plan that addressed 3 different areas. First, climate change. Second, water availability, use, and reuse. And finally, water quality. The third case study involves climate change adaptation in forests, basically throughout the Midwest and the Northeast. This is in response to warming climates where windstorms, wildfires, insect outbreaks, and floods are projected to become more and more frequent. To address the effects of these events on forests, the Northern Institute of Applied Climate Science, together with the USDA Forest Service and other partners, initiated the Climate Change Response Framework. The goal of this was to incorporate scientific research on climate change impacts into on-the-ground management. Several different products or deliverables were developed as a result of this framework. These include vulnerability and mitigation assessments, which summarized the observed and projected changes in the climate, projected changes in the forest composition, and assessed related vulnerability of forest ecosystems in the relevant areas. Also, a workbook was developed called the Forest Adaptation Resources, Climate Change Tools and Approaches for Land Managers. This was to help managers identify management tactics that would facilitate adaptation, and it included a menu of adaptation strategies and approaches. Finally, a series of adaptation demonstrations was initiated in order to showcase ground-level implementation activities. The last case study discussed in the assigned reading related to Cape Cod, Massachusetts, which is a coastal area of scenic beauty and environmental significance. This area is currently affected by sea level rise, coastal erosion, and localized flooding, which are common problems for all coastal areas with respect to climate change. And these issues are just going to get worse with increasing climate change over time. In order to address these concerns and to help meet the state's greenhouse gas reduction target, the U.S. DOT's Volpe Center worked with federal, regional, state, and local stakeholders to try to integrate climate change adaptation into existing and future areas such as transportation, land use, coastal zone, and hazard mitigation planning. This initiative was called the Transportation, Land Use, and Climate Change Pilot Project. Though climate change affects pretty much every area of the world, we chose for our case study the Louisiana coast. The Louisiana coast is an area of great importance for this country. It's not just the famously unique and historically rich and significant city of New Orleans, but the coastal wetlands of Louisiana produce much of the nation's seafood, and oil and gas exploration and production structures pepper the Louisiana offshore and onshore area, providing valuable resources for our energy needs. There's also the Port of New Orleans and other smaller ports located in some of the smaller coastal towns that also have significance for our country's transportation network. Before Hurricane Katrina hit in 2005, there was plenty of talk of the vulnerability of New Orleans and the Louisiana coast generally. There was talk about the fact that the resilience of the coastal ecosystem had been eroded over the years by many different actions. These included things like the damming of the Mississippi River and tributaries by various levee systems. This deprived the coastal areas of the sediment they traditionally received from the changing of course of these waterways. And it resulted in subsidence and significant land loss. Another action that caused problems was the crisscrossing of the marshes with oil and gas related canals. These increased saltwater intrusion and erosion, basically flipped healthy marsh areas into open water areas, thereby reducing the natural buffers that existed to help protect against extreme weather events like hurricanes. Every year there were warnings by the authorities about the big one and what it could do to the city and the coast. But it didn't happen for so long that people became complacent. In 2005, when Hurricane Katrina hit, that complacency was destroyed. There was so many different kinds of damage from Hurricane Katrina. The flooding of the city of New Orleans and coastal areas as well, a trashing of the seafood industry by destruction a lot of the boats and infrastructure, as well as destruction to the marsh itself. Oil and gas production was crippled for some time. Transportation through the ports was crippled, and even residents of New Orleans couldn't get back in most cases for many, many weeks. You can see from the pictures on the slide just a general picture of the flooding in the city, another picture of the boats that had been grounded in the extreme southern areas, and the picture on the right is my house, which was in the Lakeview area of New Orleans, about 1 mile from the levee break. And that's what it looked like when the floodwaters finally left my house about 6.5 weeks after Hurricane Katrina hit. Now, once Katrina did hit, people did wake up somewhat, and that is the good news. We know from the studies that extreme weather events will become more frequent and intense with climate change, and these effects will be exacerbated by land loss and rising sea levels that are also associated with climate change. Thankfully, these things are being taken more seriously now, and Katrina is proving to have been a call to action in terms of increasing the use of resilience analysis and adaptation programs in the Louisiana coastal area. Because it was such a high-profile, highly visible event, Hurricane Katrina brought much attention and funding to the need to better prepare for extreme storm events on the Louisiana coast. Billions of dollars have been secured and are anticipated in federal and state funding to help with adaptation efforts. Ironically, this funding includes $5 billion from the BP oil spill settlement relating to the huge BP oil spill in 2010, which further caused significant damage to the Louisiana coastal area. Louisiana has not adopted a specific statewide climate adaptation plan. However, the state and local entities have taken a variety of actions to address impacts to sea level rise, to subsidence, and to land loss. And these use resilience-type approaches, which are noted in red in the slideshow. The main state efforts toward resilience for the coastal areas have come about through a new state agency called the Coastal Protection and Restoration Authority, or CPRA. This agency was created after Katrina and leads with respect to flood risk reduction and coastal planning. It coordinates with federal, state, and local entities in working to increase resilience and adaptation. The agency is tasked with coming up with a coastal master plan approximately every 5 years. These plans use a variety of techniques, including predictive modeling, which is used to identify effective risk reduction and restoration projects. This modeling is based upon a couple of different scenarios relating to different possible future conditions, one moderate, one less optimistic. The plans have recommended a variety of different approaches, which the article calls a multiple lines of defense strategy. These include things like restoration projects to enhance the flood risk reduction benefits of those natural coastal landscapes that used to exist. These are things like sediment diversions, marsh creation projects, and ridge restoration. Another approach is the construction of structural flood protection, such as pumps, levees, and floodgates. And another approach is the local government adoption of non-structural measures. These would be things like land use policies that required any structure built in the floodplains to be elevated, for example, or prohibited building in flood zones at all. The master plans also utilize the input of multiple stakeholder groups. In fact, 33 different stakeholders, as reported in the article, including business and industry, municipal governments, and nonprofit entities. In addition to putting forward their own coastal master plan, the Louisiana state agencies have worked with local entities, including parishes, which is the Louisiana equivalent of a county, to assist in the preparation for sea level rise. And some of these local entities have initiated their own efforts. These local post-Katrina adaptation efforts include things like the State Coastal Hazard Mitigation Handbook and white papers prepared by the state agencies to help the parishes and guide them in how to adapt and how to consider the different elements of climate change in their own development plans. They also include informational outreach to residents and local governments, such as the easily accessible Flood Viewer program discussed in the article. This is something that allows residents and policymakers to map flood risks and map the potential impacts as they consider how they can work to adapt to future climate change. Some parishes have adopted their own resiliency plans. One parish even calls it specifically a resiliency plan. And the City of New Orleans has adopted a master plan that is part of the process for preparing for future climate change impacts. It includes a variety of different measures, and just a couple of these would be coastal restoration projects and development of, quote, resilience standards in consultation with the Army Corps of Engineers and the CPRA. Other actions taken by New Orleans would be elevating structures, such as in my neighborhood, where anyone who rebuilt had to utilize the first story as a non-habitable garage or above-ground basement. It also includes designing and building storm-resistant public facilities like hospitals, implementing sustainable water management to decrease flood hazards and to minimize land subsidence, and employing a chief resilience officer who coordinates and oversees the various resilience activities that are going on in the area. In addition to these efforts by cities and parishes and the state, there are various nonprofits and academic entities who have also published manuals and toolkits and have created platforms to connect the various shareholders and conducted training sessions to help them understand how to adapt to resilience. Time will tell how much of the Louisiana coast resilience can be improved by these various efforts. But there is some hope now, given the increased aggressiveness of these efforts and the level of funding that's being employed to try to make the Louisiana coast more resilient the next time a hurricane comes around.